Hello humans. So today we're gonna try to build an example for the Serverless Handbook chapter about massively distributed data processing pipelines that you can build with your existing front-end skills, JavaScript and stuff like that. There's gonna be a bit of non-front-end skills, obviously, because we're using serverless technologies and you have to set everything up. But most of all, we're going to Hello, Bert. We're gonna try to build a simple adder that takes an array. Let me zoom this picture in. So a simple adder that takes an array, multiplies every member of the array by 2, then tries to reduce them all into a single number. We're gonna try to do a distributed reduce. That part is a little tricky, but we can do at least the simple reduce version. And there's going to be a lot of copy pasting going on from some of my code that I've built at my day job, because I don't want to build everything from scratch. And there's a couple of neat utilities that I've built there. So I'm gonna go into I should have an examples directory, examples directory. And to get me started, I'm going to just copy over the GraphQL example into this one so that I have the basic serverless setup. Let's say serverless data pipeline. Yeah, that makes sense. Serverless data pipeline example. Serverless data pipeline example. We need to recursively copy because it's a directory. So it's now copying. I'm also copying all of the node modules and stuff, which is probably not the best idea. But we go serverless data pipeline example. I'm going to rmrf all the node modules. Open the project up. Let's see. Open the project. Where are you, project? Serverless Handbook, data pipeline example. And I know that the making an adder example sounds kind of dumb, but it's actually a pretty... How do I hide this shit? Come on. Why does my... I used to have a keyboard shortcut to hide that, and it doesn't work anymore. Let's see, view, appearance, show sidebar. Okay, go away. We open the package.json file, say that this is a serverless data pipeline example, a simple massively distributed adder. And we're going to need AWS Lambda, node fetch is not going to be that useful. We don't need Apollo server Lambda. We need AWS Lambda, SDK, query string, simple DynamoDB is going to be useful. And the UUID stuff is also going to be useful. RMRF, all the node modules. Come on. ls, oh, I already did that. And in source we have what? We have GraphQL, mutations, queries, and types. We don't need any of that stuff. So do we remove all of them? Yes, let's remove all of them. And actually we are going to copy something from the REST example, because the REST example is going to have like data needs to come into our project somehow, doesn't it? So we're going to figure that out later. We need to go into serverless YAML. We have the serverless data pipeline example, self-service. We're gonna need some yes, we're gonna need access to DynamoDB, and we're going to say that for now we don't have any functions because we're gonna write those later, and we are gonna have a DynamoDB table that's gonna work as our scratchpad. That's going to be where we store the final. Yes, that's gonna be where we store the final results. That makes sense. So it's going to be called the results table. Results table. Results service results provider stage has access. Result ID should have we need a result ID. We're gonna need a result ID attribute. And let's see, results table is the name of the table. So I run yarn to install everything. Cool. So now I have a basic project set up so that I can get started. we're gonna start with a simple REST API to get, let's start with a REST API to get data into the pipeline. I'm gonna go on GitHub to copy from my REST example. So serverless handbook, there we go. Serverless handbook, go into, dude, shut up. Package JSON, get the REST thing. Oh, that's the wrong one. Examples. Kiwi, be nice. Package JSON. Oh no, I'm not gonna need that, but I am gonna go into serverless YAML. We're gonna copy the function to get us started. So the getting started function, oi! Let's say, what should we call this? Sum array? Yes, because that's what we are trying to do. Sum array, that's the outward facing API. So let's make a sum array function called handler that's on a path. It's going to be a post, and the path is going to be sum array, right? Oi! Okay, so Kiwi, come here and be nice. Sorry about the bird. So this sum array handler, then we need to make the handler in source. We're gonna go from manage items, copy, and we say import API gateway event from AWS Lambda. Come on, AWS Lambda. Save in source, and we said that this is called sumarray.ts. Like that. Then we are going to need a hey nonconformist. Yes, the bird is being quite silly today. We're going to have UUID v4, which is going to this one is going to give every array that we request the results from is going to get a new ID, so that we can then use that ID to identify partial results and so on. Then we are going to have a, there we go, export const. We said that this is called the handler. Export const handler equals an async method that gets an event API gateway event, and it returns a promise with the API response type, which we're going to define right now, or rather we're going to copy it from types. So we take API response, we say interface API response. Perfect, got that. Now let's see, what else do we need? We are going to say const, what is this going to be? We said that this is a result ID. Let's just call it a request ID for now. Request ID. Kiwi, shut the fuck up. Const request ID, which is going to be a new UUID v4. So that's going to give us an identifier to use throughout the entire process. And to get the actual array, we're going to parse the body, aren't we? Yeah, event body. So const array equals JSON parse event.body. And now just to get started with this and try it out, we're going to return response 200 with status success, right? And I'm going to just for now I'm going to return the same array so that so that we can try that the basics work. So get the response status code number event.body. What is this saying? That event.body might be undefined, which we should take care of, shouldn't we? How did we take care of that earlier? If event.body doesn't exist, then we return response 400 and say status error, and error provide a JSON body. Okay, so I'm gonna yarn deploy this. Yarn deploy. This is going to be my basic. No, Siri, I'm not talking to you. So this is going to be how we get arrays into the data processing pipeline. Something already doesn't work. Item table could not be found. Where am I talking about item table? Here. We need the results table. Results table. That's going to be where the data ends up. So that's the Kiwi. Come on. Can you be nice? You used to be so nice on the live streams. He used to participate in this stuff. Now he's just a menace. And the next part I need to figure out is, I need to get the URL. And then we're going to figure out a curl command that will let us test this. And then we're going to start building the actual pipeline. So let's see. Kiwi. Hi, what do you want? Okay. So this is deploying. Now, for the pipeline, we're gonna need a couple of utility functions. Some of them are going to be for sending messages to SQS so that we can make lambdas communicate with each other. And I've built that before, so I'm gonna copy it over because I don't want to do it again. So SQS message, this is a useful one. What else do I need? Get secret, we don't need that one. We don't need the clean number, so it's just the send SQS message. And actually let's make a utils thingy here. So, utils.ts, we have send SQS message, which gets what? Come on. Import AWS from AWS SDK, and then we need to import the, do we need any types? We have the QURL. Why is, QURL message is any, we stringify the message. Why is this complaining? There we go. Now it's not complaining, and I can also move the response code there because that makes sense. So we say import response from ./utils, and we paste it here. Export function response body any. Perfect. So that deployed. I should now have. I'm gonna open a new tab. Hey Adrian, how are you doing today? So we're going to do git curl with 1, 2, 3, 4, 5. Because that's an easy one to remember. We're going to curl it to our to the API lambda, and we get back the array. So cool. The basic API is working. We now have a way to get arrays into our data processing pipeline, which is pretty important. Now I'm going to commit this git add dot. Say git commit -a -m data pipeline example accepts. You need to get away from here. Data pipeline example accepts inputs. That's what's Adrian saying. Started doing YouTube like me, yay! Nice. Well, Adrian, you should. What kind of videos are you doing? Are you just live streaming like me, or are you doing proper videos? Cool. So now the next step of this is going to be we've accepted an array. We're going to add an ID to that array, and then we're going to distribute processing. Excuse me. Now we're going to distribute the processing of this array. So the way we're going to distribute that is that we're going to put it in an SQS queue that's going to trigger a lambda to do the ×2 part. So here we say split array into elements, trigger ×2 2 lambda for each entry. So we go through. Oh yeah, my day blogs, those were fun to make, but they honestly take way too much time to do. So I kind of got lazy and stopped doing them. And I honestly realized that my life just isn't that interesting. I thought my life was interesting, but it got kind of boring. I think I just got old or something. But I should try to make more of those. So split array into elements, trigger times 2 lambda for each entry. So the way we do that is go through the array for each. We get the number, and that number, come on, number. I know what we need to do. Array is a number array, like that. Is declared, but its value is never read. Fine. So then we say send SQS message, which accepts a JSON. So we're gonna need the queue URL, and we're also going to need the actual message that we're sending. So, oi! The queue URL, I'm going to cheat and figure out how I did that at work, because it's been a while. So we need to define a queue as a resource that is down here. So I'm gonna do some copy pasting. I was thinking on my run this morning that I should build this is not a users table, this is a results table. I was thinking that I should build something like a generator for serverless, so that you can just run a CLI, and that CLI then adds a queue to your project or adds a new lambda, stuff like that. That would be pretty cool, wouldn't it? Dean, yes, I do use serverless at work. I'm building a huge project where we're currently processing, I think, just over 1 million events per day with them doing serverless processing. So it ends up running like 3 or 4 million Lambda invocations per day. It's actually really cool. And I should write about that, but I'm gonna wait until it actually starts fully working before I write about that. This Serverless Handbook chapter is kind of lessons learned from doing that project. Megdi, I'm doing great today. How are you? As you can see, I'm kind of dealing with a menace over here. I hope he's not coming over too loud on the stream. So what I said I was going to do here is create a queue for the so first we need a queue for the ×2 lambda. So we're going to say ×2 queue, which is going to look like this. It's a type AWS queue. Type AWS. Why is this not formatting? Prettier, what are you doing? What's wrong with Prettier? Kiwi, shut the fuck up already. What am I doing wrong? Properties is too indented, so it needs to go like this. Now it's happy. So we have the AWS SQS queue. We say that this is the ×2 queue. Visibility timeout 60 is great. Redrive policy, we're going to ignore that for now. I'm gonna add that later. Dean asked if serverless is more expensive than a hosted VM. It really depends. It really depends. For us at this level, it's cheaper because we don't have enough resources to deal with hosted VMs. And once you get to spiky and once you get to intense loads like ours, it's not, the DevOps work of keeping a VM happy is not insignificant. We would probably need a full-time person dealing with that. Okay, so we have that. Now we have a queue. Now I need to define an environment variable for it. How do we do that? Let's see, unpack queue URL. There we go. So we go here where we're defining the functions. We're gonna give it an environment variable that is going to be called a times2 queue URL, which is referencing the times2 queue. Then in some array, I can send a SQS message to process.env.times2 queue URL, and we're going to make sure that we know that that is defined, and each of those is going to have a request ID and a number. Should we call it a number? Let's call it a number. So we're now triggering a lambda that is going to multiply a number by 2 and then send it onwards to the next part of the queue. Hi, Bert. Okay, so request ID number times 2. The times 2 part now needs to be a new lambda. So we're going to define a new lambda here called times2, which is going to be handled by dist/times2.handler with a queue event. How do I do that? There we go. With an SQS queue event that comes from an arn with a get attribute from times2 queue and an arn, and we're going to say the batch size is 1. Batch size here is important because it tells us how many elements of the queue we're trying to do together. Bird, shut the fuck up. And okay, so that's gonna be the times. Nice. So Magdi, how did the SQS and periodic invoicing work out for you? Now I'm gonna start the file, and we're going to need, I'm gonna check what we're gonna need because I forgot. See, this is the thing I do. When I was originally doing this research, it kind of took me forever, but now it's actually, now that I can just copy stuff over, it's not that bad. So we import the SQS event and the SQS record from AWS Lambda, like that. Save this in source times2. Come on. Oh. times2.ts. Great. And what else are we gonna need? No, that's the only thing. We're gonna need import send SQS message from /utils. Now we are, no, it's not /utils, it's /utils, and we're going to export const handler, which is an async function that starts with a SQS event, right? Okay. Now each SQS event is going to give us a message that is going to be const messages string equals event records. Come on. Wow, my computer has started lagging. Perfect. O1 Pollux has a quick question. Shoot. Install the worker in EC2 instance to process all jobs on queue. Interesting. Magdi, how come you chose to go with an EC2 worker instead of using serverless or a Lambda or something? So here the thing about SQS invocations is that, wow, okay, that's annoying. I don't know why my computer is being so slow right now. It is, I guess it's probably thermally throttling, or this is just being annoying. So SQS rec, basically each time a SQS queue executes our Lambda, it gives us multiple messages, not just one message. So we have to then parse them through one by one. But what we're gonna do here is, no, actually we can do it properly. We're going to say that each of them is one. It's going to times2 one thing, but it could do multiple. You'll see you'll see what I mean in a little bit. So each record gives us a body. The body is the stringified JSON of this thing. So we have the request ID and the number so that we can know how many there are. We can identify them as it goes through. And then we essentially, this grabs messages from the queue, grab messages from queue. And we can then say const, what should we call them? Should we call them packets? Let's say packets. Actually, no. Let's do it this way. We're going to add a type for, we had a request ID and a number. So type packet equals request ID, which is a string, and come on, press enter. For the love of God, press enter. Request ID and a number, which is a number. So we're going to have an array of packets, and we're going to JSON parse those. So like that, we say packets. That makes sense. And then we go through each of those packets, multiply the number by 2. Magdi, my question was, how come you used EC2 instead of Lambda to process your SQSQ, which sounds like an interesting choice. Okay, so we have those packets. Now for each of those, iterate packets, and what do we do? Iterate packets, and we are going to do what? And multiply by 2. Then, yeah, so we iterate each packet and multiply by 2. So we say const. Now let's do let, and this is the map part. We say packets equals packets.map, where we get a packet for each of them, and we just return packet.num. What should we do? Yeah, we copy the entire packet over, and for the number we say packet.number times 2. Does that make sense, or should we destructure them? Yeah, let's do destructuring, because no. I think this is gonna be an easier to this is easy. Yeah, I think this code is going to be better to understand than the other approach I was thinking. So that multiplies by 2. Then we trigger the next step in the pipeline for each packet. Trigger next step in pipeline. So we go packets.map. For each of them, we do what? Send SQS message to process.env. So we have a ×2 lambda. Then the next lambda that we are going to trigger is going to be the reduce lambda. So we say reduce lambda, reduce queue. Let's call it a reduce queue, and we are going to put in the entire packet into the reduce queue. I think that makes sense. Yeah. Now we need to set up the next lambda. So we've done this part here. Let's make it bigger. Oh. So we've done the mapping part. We've multiplied every number by 2. Now we have to put them together, and we're going to use the batch size trick from SQS to help us with this part, because it's going to make it a lot easier. So basically, each time our lambda gets executed, it's going to actually get 2 messages from the queue, and we're going to use that to reduce the queue into a single number. So we're going to need another queue here, ×2 queue. Then we're going to say the reduce. This is going to be the reduce queue. Is that what we called it? The reduce queue, yeah. Reduce queue here. Reduce queue. like that. Now the reduce queue is going to trigger a lambda here. Let's copy the lambda. And let's just call this reduce. This reduce.handler gets triggered from the reduce queue. And batch size is 2. And we're gonna say that we rely on the batch size to slowly reduce things. Rely on the batch size to help us for the what's a good word to use here? What's the verb for reducing things? To send two messages for each invocation. To grab 2 messages with each invocation. Okay. Like that. Then we need to create a new lambda. Yeah. Bam. Oh, actually, we should put the type in utils. I know utils is not a great place for types, but it works for now. Packet, packet, and we save this as the reduce.ts times 2 also imports packet from utils. Like that. Reduce.ts handler, did we call it handler? Yes, we called it the handler. Grab messages from queue. We rely on batch size to ensure there's more than 1. So we get each packet, then we sum packets together. We say const packet, and we say const next packet equals packets.map with a sum and a packet, and we do what? So we are going to return, we should also start with a 0, and we say that we're summing them all together. So for each one of them, now let's say const sum, because that's going to be easier. Sum is going to be just sum plus packet.number. Packet.number. Why is it complaining? Number does not exist on type number. So is it actually like this? There we go. I always get those two mixed up and turned around. So we get the sum. Now we need to trigger the next step. Trigger next. Okay, so there's gonna be a tricky part here. Trigger next reduce. So when we trigger the next reduce, what do we need to make sure. So for now, let's keep it simple for now. Trigger the next reduce. The next reduce is going to be send SQS message process.env.reduceQ with the packets 0.reduceID. Yeah. What is this complaining about? Oh. So reduce ID, and we are going to say number is a sum. It's not reduce ID, it's the request ID. So if you've Shouldn't that map be a reduce? Julian, which map? Yeah, you're right. This map. You are definitely right. It should be. That's why it wasn't working. Parameter packet, no overload matches this call. So reduce previous value and the current value. And the previous value is also a packet. Is it? Oh, does TypeScript not let us use... that's annoying. It would be nice if TypeScript let us use... yeah. So the problem is that TypeScript doesn't let us use reduce to change the type of what we're doing. So we gotta first map it. We're gonna go like this. Thanks for pointing that out, Julian. We're going to map each packet into packet.number, and then we're going to sum them together as sum plus num, and that should work. I don't understand what it's complaining about. Oh, is it not returning? There we go. So we sum them together, and the problem here, to do no guarantee they belong to same request ID. We triggered the next reduce with the request ID, the number sum. Yeah, Magdi, you're right. I wasn't returning stuff. And then we are triggering the next one. Now the question is, first, how will we know that we've actually how will we know that we've when we're done? Because we've lost the information of how many elements there are in the array, so we need to fix that. We're going to go here and say total n is also a number, right? So each packet is going to need to contain the information on when are we actually done with this. So here, when we are summing the arrays, we're going to have to add the total n. No, let's say length. Length makes makes more sense. Length, array length, which is array.length. This way we're going to know when we're done, and then in ×2 we kept all of that alive. We're just multiplying the number by 2 here, and we need to figure out how to guarantee that that everything belongs to the same request. And actually, let's, instead of request ID, let's call it array ID, because I think that's going to be easier to understand. Some array, we say array ID. Array ID is a new UUID v4. Then in reduce, we have array ID, and we have the array length, which is now the previous array length minus, so we say dot array length minus packets.length, right? So this makes it so that we're going to eventually get to a 0 array length. We're going to say here, if, actually let's do it like this, const how much work is left, const array length equals packets 0 dot array length minus packets dot length, like that. Come on, what's wrong? Oh, that's what's wrong. Now, if array length is less than, if it's less than or equal to 1, then we save the result, else we trigger the next step. Save result. Now, when we are saving the result, we are going to use my DynamoDB library, which is designed to be pretty simple and easy to use. So we go simple DynamoDB, source. Oh, I actually have documentation, don't I? Update item. There we go. Also, what the hell happened with my Brave? All the fonts are weird. So we import asterisk sdb from simple DynamoDB, and then we go here and we say db dot update item. Wait, oh, and we need to return true from each of these. So return true, and in reducing we also return true. Now await db update item. We're going to say that table name is process.env.results table, and we're gonna need the key, which is going to be process. We said that it's going to be, we said here we have request ID, but we should change that to be, oh, result ID. Perfect. So result ID is process packet 0 dot array ID, and we, hey Michial, sorry, I don't know how to pronounce that this early in the morning. Also my mouth is getting really dry. And update expression set, we say, what do we need? Build expression body. Do we need that? That makes sense, yeah. Let's just use it. db.build expression, which is going to be from the body. Actually, no, we don't need that because we're saving just one value. So we say result equals, what does result equal? Hydrate, yes, I do need to hydrate. Fuck, how did I forget how this works without the build expression part? Let's see, DynamoDB TS, build expression. Ha! So result equals result, and then we have expression variables, right? Come on. Simple dynamo. Expression attribute values. Is that what it's called? No. Scan items, delete items, build, update. Expression attribute values. Expression attribute values, which are going to be result is going to map to sum. So that's going to be our sum. So now in theory, I should be able to deploy this, and it should just work. It's been a while since I should have run this more often, but let's try. Let's try deploying it and see what happens. So it's going out. Come on. Deploy faster. I'm gonna actually hydrate in just a sec. Alright, it's still deploying. So now the interesting part is going to be how do we make sure that when we're reducing numbers, because right now the entire data processing pipeline only works if there is one request at a time. Results table already exists in Stack. Ah, yes. So one of the problems with serverless, I don't know why that happens, is that you can't just rename shit. Results table. So what can I do? Instead of just renaming it, I can... Should we just call it results 2 for now? Yeah, let's do it results 2 for now. I'm annoyed with that. Fuck it. Results 2, yarn deploy. Actually, no, let's call it sums. Haha, sums. There we go. Yarn deploy, deploying it again. So the what I'm not sure how to resolve, all of this was pretty simple, but it only works if you're sending one request at a time and waiting for the processing pipeline to finish, because the summing part currently doesn't understand that packages from different array IDs can get mixed up, and I am not entirely sure how to fix that. So that should be pretty interesting. But let's see let's see what happens. Yeah, so if array length is less than 1, that means we've processed everything. Otherwise, we trigger next reduce step in the pipeline. And let's see. So this is almost deployed. And then we can try running it, and we can see we'll see if it works. Wow, computer. Ba-ba-da-bum. And while that's deploying, I can go to the AWS console, look at my account. Okay, OBS crashed. I should be back now. Let's see. So this is still deploying, but I should be able to, what should I be able to do? Well, no, I'm just waiting for it to deploy. Okay, come on, deploy faster, computer. This is interesting. I'm gonna have to look into Fargate. All right, come on. You can do this, computer. Stack update finished. Great, so we now have functions SumArray ×2 and reduce, and we should have SQS as well. Let's see, come on. SQS, simple queue service. Simple queue service. Let's see. Okay, so why do I have all of these guys? I should have, what are we looking for? We're looking for the ×2 queue. ×2. Oh, come on, what did we name it? ×2 queue. OBS crashed again. Oh no, that was from before. So we have the ×2 queue, and we should have the reduce queue as well. Great, we've got both of those. Now let's see if we run the SumArray curl. Okay, that ran. Now the reduce queue should have some messages available. No? That's interesting, but the ×2 queue definitely should have some messages available. Messages available, messages in flight. Maybe it's already finished. or maybe everything crashed. Let's go to DynamoDB and see what happened. So we've got DynamoDB, we can go to tables. We named this table the sums. So if we go to sums, items, it's empty. Great. So something failed. Now what failed? Let's go back to AWS and we can check. What can we check? Come on, computer. AWS Management Console. Find my Lambda, and we're gonna look for if this. So the sum array Lambda shouldn't have failed because it returned a. It successfully returned the result. But maybe the ×2 Lambda is what failed. No? Come on, Lambda. So serverless sum array monitoring. Wow, computer, why are you so slow? What's the point of buying an expensive computer if it can barely do streaming and stuff? Okay, so there is an error count here. What were the errors? Were there actually any errors? I did update to macOS Catalina, I think. So, and I know that OBS has some trouble with that. Yeah, I'm on Catalina. Now let's see. This seems to work just fine. Triggered at 25. No, that seems too early. This is the latest one at 9:02. It did SQS, so that worked. We send these messages to our queue, so that's great. The queuing worked. Now, did our lambdas actually run? Functions. What is it with the ×2 lambda? What did we call the ×2 lambda? We gave it the name ×2. So is it in functions? There we go. This one is in functions, and this one should have ran 5 times. Let's see if it did. It does say that it gets triggered from SQS. That's great. And if we go into monitoring, what happens? Error count and success rate, no data available. View logs in CloudWatch. Did you actually get triggered, Mr. Lambda? Or is it Miss Lambda? It does not seem like it actually ran. So that's weird. It looks like sending a message to SQS didn't actually manage to run our Lambda. So why would that be? We are SQSing. What does SQS? Return new AWS SQS, send message promise, sum array. Aha. We're not waiting. So we weren't waiting long enough for the SQS to actually work. So what we can do instead is say for let number of array. Is it that one? I always forget if it's for in or for off. Let's do for n of 5. Console log n. Okay, yeah, it's that. Miha, this is actually a new computer. That's the problem. So I don't know why it's being so slow. Okay, and then we wait for this thing and deploy again. And now I think it's gonna work. Deploy. Yeah, thanks, Robin Malfate. You're right. Oh, nice. Jean, what were you building the other day? I'm really curious. Let's see. Okay, so this is now deploying. I'm pretty sure the problem was that we didn't await for send SQS message to actually work. Are we doing it here? New. So I'm gonna cancel this deploy and start a new one. And fuck me, we need to make sure we await here as well. For let packet of packets await. This is a very common mistake to make, I think, is to forget that you need to actually give lambdas time to wait for asynchronous code to finish. Otherwise, that code doesn't work. Okay, so this is deploying. Now, I'm really curious what Jean was building the other day that was similar to this. And then when this works, probably not this weekend because I have some other stuff going on, but maybe next week, I really want to try to build a distributed quicksort algorithm that works, that sorts numbers using this kind of similar approach. That would be cool. Webhook to queue to lambda hack because he built it too many bloody times. Perfect. I would love to see that. But I really think that I've been thinking for a while about building a CLI that helps you do, on this stream, I did a lot of copy pasting and things that are very similar to other things. All of that could be a CLI. So I've been thinking for a while about building a CLI like that. I just haven't done it yet. Maybe I should. Now let's see. Okay. Cool, that deployed. Now we're gonna run curl again and go see if it worked. So we're curling. Internal server error, nice. That is progress. I know it doesn't look like progress, but it actually is. What was the error? Uh, 909, that's what we did. Where is the error? There we go. Access denied. Haha. Okay. So typical Amazon problem or AWS problem. You forgot to set up permissions. So again, more copy pasta because I really, where is it? There we go. Source log entries. Let's see, serverless YAML. I always forget to set up permissions. So I'm gonna, oh nice, that sounds like a good idea. Let's just give it all permissions on all of SQS. What could possibly go wrong here? SQS queues, what could possibly go wrong? Okay, we deploy that again, and yeah, that's not a good approach, but it'll do for now. This is just an example. Remember? Ow. Okay. Come on, deploy faster. Bad indentation. Effect allow. Oh yes. Now let's do it again, yarn deploy. So this is also one of those things where a CLI would be really useful because it could just do this for you. I wonder if serverless actually has a CLI for that and I'm just too dumb to know about it. That would be pretty interesting. Okay. Come on, yarn deploy. Oh, it's getting late. We're gonna have to wrap up soon. I'm also realizing that because my chat is down here, I always, when I'm talking to you, look down and away from the camera instead of looking into the camera. That's a habit I need to fix. Now let's see. Deploy, deploy, deploy. wonder if you can actually hear the music now that my monitor doesn't have speakers. Oh, come on, deploy faster. Checking stack update progress. And what is actually the problem with my computer? Why is it downclocked to 2.4 gigahertz? Okay, so that did the thing. Now let's curl again. Curl, please succeed. That succeeded. So we should now see invocations in this lambda. So the sum array lambda should have executed now, didn't it? The API lambda SQS things, that seems to have worked. Now let's see, DynamoDB, did you get any data in the end? No. Are there any is there anything on SQS for this stuff? We can say the ×2 qdev has 5 messages in flight. Yes. So that means that this is going to try to execute our ×2 lambda 5 times. Monitoring. So we have 5 messages. I don't know what an empty receive is about. So that seems to work. Lambda triggers are enabled. And what are these lambda triggers? Are they triggering? It's going to this lambda here. Did it manage to run? Come on. Aha, no. View logs in CloudWatch. Did you actually... Why did this lambda not trigger? Oh, it did. Okay. So we have this lambda ran 5 times. Unhandled promise rejection. Missing required key. Q URL in params. Haha. That's what we're doing wrong. So we need to, here where we are defining the lambdas, we missed an environment variable because the ×2 lambda needs to have the reduce. So the reduce Q URL, which is going to be the reduce Q, and then the reduce Q also needs that here. So reduce Q, and now here one of the good things you saw here is that the SQS keeps retrying for a while, which makes our system more robust. So even though this has been failing, it might still work as soon as if we manage to redeploy before those messages time out. So that's the main reason I like to use SQS instead of SNS, is that SQS stores your messages and keeps retrying until your lambda eventually works. So this should in theory just keep going, and when I redeploy, if it happens fast enough, and I'm not entirely sure how long we have, but it should be able to then catch this problem and do the thing. That's a weird way of saying it, but basically the idea is that if we deploy the fix before those messages time out, it's going to, on the next retry, work, and then the rest of our pipeline is going to work just fine. And that's why SQS is better than SNS for if you need robustness, but it is a little bit more expensive than SNS by very little. Like if you're not processing hundreds of millions of events, I don't think you'll even notice. And the added robustness is super useful. Okay, come on. Checking stack update progress. Do the thing. Yeah, Magdi, you're right. You can also customize your retry policy. And one of the things that I like to do is to customize it in such a way that it eventually puts stuff on a so-called dead letter queue, where it sits for you to go through and fix problems later. Okay. So, let's see. This should now start succeeding. Duration, do we have a success? Success down here. Still no successes, but let's see if the SQS queue is doing any better. We said that this is the ×2 queue. Oh, really? You have to... It's case sensitive? Why would they make this case sensitive? So it still has 5 messages in flight. Does it have fewer now? Still 5 in flight, okay. So if we go to our ×2 lambda and go to, is it here? Let's close this one. I'm getting lost in all of my tabs. This is the ×2. And if we go view logs in CloudWatch, we should hopefully see some successes start piling up. This is from 9/18, that should be fairly recent. Unhandled promise rejector. Queue URL in params. What does it mean it's missing queue URL in params? This would be SQSing array ID blah, array length 5, number 10. This is happening on missing required key queue URL in params. So process env reduce queue. This is the only time we send the thing. ×2. Oh, god damn it. I named it differently. Reduce queue URL, and here we also have reduce queue URL. Cool, try again. And now hopefully it's gonna work and I can get to my actual work. I also don't think this chapter is gonna be ready today because I still have to write it. But at least we're getting the example ready, right? Okay, come on. This is always the boring part when you're deploying things and just have to wait around and kind of... I try to keep you entertained, but who knows if it's working. Come on, Mr. Computer. This part, damn. But yeah, I'm really curious if you can hear the gentle background elevator kind of music. All right, now, will this work? Okay, we go to example dev ×2. 921, it already ran. Did it work? Oh, this looks like it worked. Yes. Okay, so that executed. We should now go here and not have any messages in flight anymore. Perfect. And if we go to the reduce queue, the reduce queue also has no messages in flight, which might mean we've already succeeded with this thing. DynamoDB. Tables, and we should have a results table or sums table. Example sums. Please have a row with our result. Why doesn't it have a row with our result? That's a problem. Okay, why the... So Why didn't the result get written to our table? I did await. Let's see. If we look for the reduce thing, reduce monitoring, did it run? CloudWatch metrics, no data available. View logs in CloudWatch. Come on, did you run? It did not run. That's interesting. So why didn't it run? What is it getting? Oh, damn. Batch size 2. Okay, so my camera died. I should be moving again. I'm not moving. Let's see. There we go. Now I'm moving. Now, why didn't this work? So we executed all of the times 2 lambdas, didn't we? Now this is where in a more oh, that's why it doesn't work, because they're additive. So in a more proper system, in a production system, I would store each step into a DynamoDB so that it's easier to debug things. But I figured we can go raw for this part. And now, of course, I can't debug it and I don't know what's wrong. Let's see. So this all triggered the reduce queue. And let's see, does the reduce queue have stuff? Simple queue service. Come on. And if we say the times queue, the times queue has no messages in flight, and the reduce queue doesn't either. So what happens? Why wouldn't this work? We are using the same times 2 queue, reduce queue. Batch size here is 2. Reduce queue URL. And we are calling it the reduce queue, which should be fine. Visibility timeout, that's all great. Reduce then does the things, but it never even triggered. What happens if we just run it, try to trigger everything again? So let's see. The times queue should now have messages in flight. No? Did it already do the things? Okay, so the times queue already did its thing. Put the next stuff on the next queue. It is triggering the reduce queue dev, but the reduce queue, oh, there we go. Reduce queue has 79 messages in flight with 1 message available right now. Is anything saving here? Nothing is saving. So I suspect something is wrong with how we are requeuing things from the reduce part. Let's see. Reduce queue now has 79 messages in flight, 110 messages. So we are dealing with a infinite recursion problem. That's awesome. Why do we have the infinite recursion problem? Let's see what's going on. Example dev reduce. Monitoring. View logs in CloudWatch. And you'll see that when I reload this, there's going to be even more. Oh, now there's 106 because 35 are, yeah, You see, messages are infinitely increasing, and this is something that if I don't stop it, could become a very expensive problem actually. So that's fun. View logs in CloudWatch. Oh God. This could cost me a lot of money. Validation exception. Aha. Invalid update expression. Attribute name is a reserved keyword. Reserved keyword result. Okay. So we're going to say, instead of result, let's call it a result sum. Is the result sum, and then result sum, and quickly deploy this again. Yarn deploy, and that's hopefully gonna fix it and improve the infinite recursion problem, because oh no, we don't want to trigger. Oh God, that's what's wrong. Okay, that's what I did wrong. Okay, you know, you guys, you could have told me that I'm building infinite recursion when you were watching my stream. It's not very nice of you. I'm really curious, if I let this run, if you let an infinitely recursing lambda function run, how expensive would that get? Probably it can get very expensive, because there's nothing detecting that you're doing something stupid and breaking you out of the cycle. And AWS is gonna happily just keep charging you, which is also not great. Yeah. But this should fix it, I hope. This is probably gonna fix it. Okay. I'm gonna leave that as an exercise to the reader to deal with the stuff. And now let's see if this deploys. Come on, deploy, baby. There we go. So that deployed. We should now start seeing a reduction in messages in flight. Yeah, that, you know, Magdi, that sounds like an infinitely wise idea to limit how much they can charge me per day. But we now have, this is now going down, that's great. Let's see if anything has showed up in our DynamoDB. How do I get out of this? Okay, let's just go to DynamoDB and see if anything shows up. I'm assuming it's going to have the wrong result, even if it did show up. Sums, items, aha, result sum 6. That is probably wrong. So I'm gonna let this finish up. Okay, now we're gonna try to do another curl, and I think the result of this should be something like 50? No, 30. Let's see, packets array length, packets my dot length. Oh, we could just do array length actually. Like that, and the number is sum, and array ID is the same. So let's run curl, and we will now get messages in flight on reduce, or maybe we missed it already. Did it already show up here? Result sum 10. That also seems wrong. Also, why did it override that thing? Let's see what's going on. Example dev reduce, running at 9:30. Everything seems fine here. Cool. DynamoDB, reload. Why do we get 10 instead of the actual result. Times 2 definitely. Oh, trigger 8. Okay, let's fix this. For, didn't we already fix this? I'm very confused. Okay, let's do for let packet of packets. We await for each one to make sure that they get correctly summed up. And I'm gonna deploy this again. Yarn deploy, and this is going to be, this is for sure going to be the last try because I need to get ready for my day job. The good thing about working from home, because of all of the things going on, is that the switch from working on this on playing around with stuff like this to working on day job stuff is relatively quick. Otherwise, I would literally be late already by now. So let's see. This is the last attempt. At least the infinite recursion is gone. That's good. I'm also not sure why aren't we getting a new UUID every time, which we should, but maybe it was because of that bug over there. Okay, come on, deploy. I'm gonna commit this, git status, git add. Do we need to add this? Yeah, whatever, might as well. Git add dot, git commit -a-m. What are we? Oh, I don't need .serverless on git remove, so I'm gonna have to wait before doing that. But let's see. Yeah, thanks for watching the loop. I don't know how to pronounce that. I find that when I don't know how to pronounce a word, I often pronounce it in Slovenian or a combination. So this is now sending the array. Is anything showing up here? Messages in flight? No. Any new results? Haha, we got 4. That also is wrong. Okay, so I'm gonna have to debug this later and play around with it, but the actual distributed processing part is working, right? We split everything up into multiple lambdas and then reduced it back together. I don't know why the result is wrong. I'm gonna have to add some console logs to track that, but I think this has been a fun and Romanian word, loop. Okay, so this has been, I hope this was interesting to you. It was definitely fun for me, and luckily we didn't melt my credit card with infinite recursion. That's great. So thanks for watching and enjoy the rest of your day. Bye guys. Or bye girls, bye folks.